In this lesson, I'll show you how to solve related rates problems with derivatives. This is question 1 in the series. In related rates problems, there are two quantities changing with time. The rate of change of one of the quantities is given and the other must be found. The trouble with answering related rates problems is finding an equation linking the variable in the given rate with that in the unknown rate. After we read the question, you'll see what I mean. The question reads, a 20-foot ladder leans against the building. The foot of the ladder is pulled away from the building at a rate of 2.00 feet per second. That's a very important number. That's the rate of change for the speed along the horizontal with respect to time. We need to find out how fast the top of the ladder is falling when its foot is 10 feet from the building. So we need to find out the speed at which this part is falling when the horizontal reaches 10 feet. The only formula that I can think of that would relate x and y for what appears to be a right triangle is the Pythagorean theorem. So let's go ahead and write down the Pythagorean theorem with reference to x and y. The Pythagorean theorem is a squared plus b squared is equal to c squared, where c refers to the hypotenuse and a and b refer to the legs, in our case x and y. So I'll replace a with x, so it becomes x squared, plus y squared, b with y, and c is equal to 400 because 20 to the power of 2 is 400. And I'll also write down what I know. I know that dx over dt, the rate of change of x with respect to t, is 2. I know what x is equal to. X is equal to 10. So by substituting x is equal to 10 into this formula, I can solve for y, which will represent the height of the top of the ladder. And then what I can do, according to the procedures above, is take the derivative of the equation with respect to time. Only then can I substitute my given information into the derivative. So by deriving implicitly, it will enable me to find the speed or the rate of change of dy with respect to time. Okay, let's go ahead and do that. Let's first find out what y is when x is equal to 10. 10 to the power of 2 plus y to the power of 2 is equal to 400. Bringing 100 to the right side gives us 400 minus 100. We square root both sides to give us the square root of 300 is equal to roughly 17.3 feet. So when this part of the ladder reaches x is equal to 10, y will be 17.3. The next step is to take the derivative of this function implicitly. Taking the derivative of x to the power of 2 is 2x. 2x dx over dt, remember it's with respect to time, plus the derivative of this is 2y dy over dt, and the derivative of a constant is 0. The good news now is we have dx over dt, and that was stated above. It's 2 feet per second. We have x, that's 10. We have y, 17.3, and all we have to do is find out dy over dt. 2 times 10 times 2 plus 2 times 17.3, and this is our target, dy over dt. All we have to do now is isolate for dy over dt and we're done. 2 times 10 times 2 is 40. Bringing it over makes it negative 40. On the left side we still have 2 times 17.3 dy over dt. dy over dt is equal to negative 40 over 2 times 17.3. Let's find out the rate at which this ladder is dropping. Negative 40 divided by 2 times 17.3 gives us a rate of negative 1.15. Negative 1.15 feet per second. And that's expected because if it's going downwards, that negative illustrates that. And so there you have it. That is how to solve related rates problems with derivatives.